So it says the cell phone plan for company C costs $10 per month plus $15 per gigabyte for data use. The plan for company D costs $80 per month with an unlimited data. Okay. Rule C gives the monthly cost in dollars of using gigabytes of data on company C plan. Rule D gives the monthly cost of dollars of G gigabytes of data on the company's plan. Using function notation, write Rule C and Rule D. So just as a reminder, okay, this is a reminder, function notation. If I have something like this, this is saying, hey, you have an equation and its name is X. Okay, if it said G of X, hey, you have an equation and its name is G. Okay. The input is what we put as the X values. The output is what we produce. Input is what we put in, output is what we produce. Okay, so right here, they are asking us to give the monthly cost of using G gigabytes. I'm gonna tell you right now that the input is going to be G. How much do we charge per gigabyte? 15. But we know for plan C, we're gonna at least say 15 times G. And how much does it cost per month? Okay, so we're gonna say plus 10. Cool. All right, so looking at the plan D, it says that it costs $80 per month, no matter how much gigabytes we use. So it's gonna be a constant. So we're just gonna say equals 80. Do you see how I got that? On your interim that has 15 questions, one of them is going to be write the equation for this scenario. That's going to come up, okay, which we just did. Now, the next one says, write a sentence describing the meaning of the statement C of 2 equals 40. So if I take 2 and I plug it in here, that represents 2 gigabytes. And when I simplify that, that's going to equal 40. So how much is it going to cost me? Well, it's going to cost $40 to do 2 gigabytes for this first plan. So everybody see it? Okay. So on number 3, it says, which is less, C of 4 or D of 4? So how would I go about solving this one? C of 4, D of 4. How do I go about solving this one? How would I go about solving that? Well, they got parentheses in here, and that represents our X, right? So we're going to take 4, and we're going to plug it into our equation. So we've got 15 times 4 plus 10. Somebody put that in their calculator and tell me what you get. And then D of 4, that's just going to equal 80. Because no matter how many gigabytes I spend, it's going to be $80. So what's 15 times 4 plus 10? 70. Okay, so which one is less? C of 4 is less. Okay, so let's talk about 4 really quick. So we're going to take each one of these numbers and we're plugging it in here. So that means for A, we're going to do -1/2 times -8 plus 9. For B, we're going to plug in -2 plus 9. C, we're going to plug in 0 plus 9. And we're going to simplify. So this will give me 4 plus 9, which is going to give me 13. This one's going to give me 10. And this one is going to give me 9. Okay. Any questions on that? Okay, you're going to do the exact same thing over here, except now you're going to use this equation instead. Notice how whatever corresponds to the outside letter corresponds to where you're going to plug it in. Yeah. So this says H, so we're going to plug that in. And then we simplify. So this will give us 22. This will give us 10. And then this will give us negative 16. So negative 14. All right, so on 7 is something that you might see on your interim, definitely with word problems. So it says an anthropologist used the length of a certain bone of human skeleton to estimate the height of the living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of X, here's the function. It says find H of 46. So what are we going to do here? We're going to plug it in. So we got 61.41 plus 2.32. And we're going to plug in 46. Can somebody type that into your calculator and tell me what you get? $61.41 plus 2.32 times 46. So we get 160. Okay, 168.13. And so what does this mean kind of in context? Well, this means that for a femur length of 46 centimeter, femur means that there is a woman who is 168.13 centimeters tall, because it tells us that the height of the female is what we're finding if we have our X value. All right, number 8, there's definitely one of these on your test. So this says F of -4. So we're going to go over to where it says X is -4. And we're going to go up to where it meets the line. Now that Y value is 2. So that's where it equals. We're going to do the next one. When X is 0, where does it meet the line? Well, it happens to be at 0. Can you try C and D? Okay, so F of 2. So when X is 2, it meets the graph at -2. When X is 5, meets it at -1. Okay, again, these will be on your test. These definitely will be on there. Okay, it might look a little different. It might be a different context, but very, very similar. Okay, we're going to come back to unit 2 and all of that. So just hang on to that interim review really quick. But go ahead and open your Desmos and go ahead and join if you need. Okay, so hopefully you had a couple of minutes to kind of like play with somebody on the polygraph stuff. Go ahead and go to slide 2. And so now it's your turn to make a parabola. Drag the points to see what kinds of parabolas you can make. Once you make a parabola, go ahead and continue to the next screen. So take a second, try to build your own. You can move these dots around to change it up. Okay, go ahead and take a moment. Amma says her parabola turns around at 3. Select a parabola that could be Amma's. Take 1 minute, go ahead and do that. We're gonna go over the answers. So turns around at 3. Turns around at 3. All right, so majority of y'all said this one. Okay, majority of y'all said this one. Okay, the correct answer is this one, or you could also have put this one down here. Okay, this is okay, because it does turn at the X value of 3. So some of y'all put the Y value of 3, some of y'all said the X value of 3. Okay, good. All right, so mathematicians call this turning point a vertex. We talked about this on Friday. It's a maximum or it's a minimum. So it's just a fancy way of saying max or min. Okay. Drag the point to -5, 1. No. Okay. Paris, I don't think she's here. So drag the point to -5, 1. Remember, the first number that they give you is the left or right. So -5 is going to be to the left, and then we're going to go up 1. As her parabola has an x-intercept at -2 and looks like a smile. Okay, drag the points to show what her parabola could look like. Okay, again, x-intercept is where it crosses the x-axis. So go ahead and take a moment, try that one. All right, so Katie says her parabola has an x-intercept of -2. So let's look at what you put. Okay. Nice. Okay. So as long as it crossed the x-axis at -2, then you were good. Okay. All right, now concave up and concave down. So many times we'll say facing up, that's looking like a U. Facing down would be an upside down U. Okay, so concave up would be facing upwards. Okay, so drag the point to create a concave down with a vertex of 4, -2. Okay, so remember, vertex is going to be your maximum or your minimum. If it's facing down, is that going to have a max or is it going to have a min? If it's facing downwards, is it going to have a max or a min? No. It's going to have a max. Okay, so here's my vertex. I'm going to move it to 4, -2. Okay, now you could have changed this up a little bit and moved these farther or closer together. That's okay. Okay, most of y'all did that. Good. Okay. All right, on 7, it's time to make some parabola art. Drag the points to see what kinds of parabolas you can make. Once you make a parabola that you like, press capture parabola and add it to your developing artwork. Okay, so go ahead and take a moment, working on that. All right, so hopefully you made some art. Okay, so now how are these parabolas alike? Describe as many similarities as you possibly can. Okay, so using the vocab that we've learned, we've talked about x-intercept, we've talked about concave up and down, we've talked about vertex, max and min. Go ahead and take a moment, describe as many similarities as you possibly can about all of these, okay? I know this is kind of slow, but the more that you use the vocab, the easier this is going to be. So majority of y'all said it's facing up. Most of y'all have said it, they all have U shapes. The X, so the axis of symmetry, they all have the same line, okay? So looking at these again, they all have the same straight line up and down right here. They all have the same X value for their vertex. They all have a minimum. They don't have a maximum, they have a minimum, okay? All right, good. All right, go ahead and take a moment and go ahead and see how many of these you can do. The goal is for you to get, I think it's as many stars as you can. Okay, so go ahead and take a moment. You're working on slide 9. Okay, so briefly, let's talk about a couple of things. 1, if I want to make 0 x-intercept, it just needs to be off the page or off the line, right? It just doesn't need to touch it. What about 1 x-intercept? I can make the vertex touch that line. 2 x-intercepts, I can bring it below the line. Okay, now here's a tricky one. Y-intercept. Okay, so I can make it where, will it ever touch the y-axis? It'll eventually touch it, right? Like no matter where I move this, it's eventually going to touch the y-axis. Okay, so I can't have 0 with me. Okay, what about 1 y-intercept? Well, of course it's going to have 1. It's going to cross the y-axis at least once. What about 2? I may have 2 y-intercepts. No, not with this type of function, right? It would have to like cross, like it would have to look like some craziness like this. And that's not a quadratic, right? Cool. Okay. All right, go ahead and skip to slide 11. Go ahead and skip to slide 11 and go ahead and complete that one. Remember, if I'm moving my vertex, my vertex is the highest point or the lowest point. Since this one is facing down, this is going to be a maximum, right? And this is going to be at 5, 3. So that means I'm going to move it over 5. Sorry, I'm going to move it over 5, and then I'm going to go up 3. And then I'm going to put that dot. Okay. For 2, 0, remember you can move the things in or out. Okay, so if you take a look at this one, okay, what this person did is they plotted that vertex, and then they made sure that their x-intercept went through 2, 0. That was it. Okay. This one, everybody's kind of similar. It's about the same. Okay. So now what I want you to do is we're going to go to another Dennis lesson, and hopefully this will move up pretty fast. We have all of this wonderful knowledge. Okay. Yep. Yeah, you can't see on your end correct or not correct, but on my end I can see that. So if I have a y-intercept at 0, 6, okay, and a line of symmetry at x equals -4. Line of symmetry tells me what my x value is for my vertex. Okay, so let's go ahead and move that guy. So my vertex is going to be moving over where x is -4. Now, this part where a y-intercept of 0, 6, I see this guy, like this line. I'm going to bring this one down and get it to pass through 0, 6, which is right there. Okay, so we have an x value of -4, and then it's going to pass through 0, 6. Does everybody see how I did that? Line of symmetry tells me where my x value is for my vertex. Okay. Now you could have done it the other way around and like flipped it upside down, but this is one of your answers. Okay. Go ahead and continue. I knew this one was going to give you a little bit of problem. This is the last one. Okay. So let's kind of chat about this. Let's talk about the graph first. Okay. It says which one of these has an x-intercept at 10? So we talked about Friday or Thursday that we had a line of symmetry, and that means that these are equidistant on both sides. So for instance, the next point would be right here. The next point would be right here. The next point would be like right here. And the last point would be at x-intercept. Okay, so it's the same on both sides. It has to be a reflection. So that means that at least f of x does work, right? Now, on the next one, we talked about on Thursday that if you find the first difference and they're the same, they're the linear. If the second difference is the same, then that's a quadratic. So from 12 to 21, that's going to give me 9. And then the difference from here is going to be 3. So we have to figure out how far this goes. So 21, okay, just find the next number. What you're going to do is you need to have a difference of 3 here. So what number can I put here? 6. So what's 21 plus 6? 27. So that's when x is 4. Okay, now we're going to keep going. Okay, we need to have a difference of 3 here. So what would be right here? So what two numbers can I subtract together? Give me 3. 6 and 3. So 27 plus 3 gives me what? 30. And so that'll give me 5. Again, on the next one, I want to find a difference of 3. So that's going to be 0. So 30 plus 0 gives me what? 30. Okay. Now we see that this is the same number, which means that our maximum is somewhere in here because our numbers are going to start going back down. So the next number is going to be 27, then 21, then 12, then 0. Well, that's going to get us a pass. Sorry. This will be here. The next one will be at 21. The next one will be at 12. And then at 10 comma 0, we'll have another x-intercept. So this should have been both. Okay. We got to understand that it's a reflection across that line of symmetry. I know this is a little tricky, so we're going to get more practice with this throughout the week. But this is how you could do it. Okay. Just kind of want to use this as like a review a little bit. If you didn't do too great on unit 3, here it is again. Okay, so, and I am going to write pretty big so that you can actually see. So we've got square root of 112. I see that this is an even number. I'm going to go ahead and I'm going to divide it by 2. Okay, and that's going to give me what? 56. And I can divide that by 2, and that's going to give me what? 28. And then I can divide that by 2, and that gives me 14. I can divide that by 2, and that's going to give me 7. And now I'm looking for groups of 2. So we can pull out this guy, and we can pull out this guy. So 2 times 2 would give us 4, and we're left over with 7 inside the radical. Okay, some of these questions are that simple. And then some of them are going to ask you to multiply or add or whatever. Okay. No, you cannot use the yellow calculator on your intro. You have to use Desmos. Okay. All right. On number 2, we've got the square root of 18. That's divisible by 2. It's an even number. I can break 9 down into 3 and 3. I see that that's a pair. So we're going to have 3 square root of 2. Right. On the next one, we've got square root of 72. So this breaks down into 2 and 36. I can break that down into 6 and 6. I see that there's a pair. So we're going to have 6 radical 2. On number 4, a lot of you made this mistake on A, your test, and B, on your mastery check. So on number 4, if you take the square root of 121, it's going to give you 11. Sometimes it really is a whole number. Those are called perfect squares. Okay, some of y'all wrote some crazy stuff. When you take the square root of a perfect square, it comes outside of the radical. Okay, go ahead and take a moment and try 5, 6, and 7. Try 5, 6, and 7 because I don't think y'all. So let's check. So we've got this negative 875, and we notice that there is a little cube in that little cubby hole. I know I can break this down by 5. Okay, so that's going to give me, I'll get 155 when you do that. I don't trust myself. It's too early. So 875 divided by 5, 175. JK, going back. 175. Okay, and 175 can be divided by 5, and that'll give me 35. Say again? It is negative. We're going to address that in just a second. We're going to do that in a second. Then we got 35 underneath here, and so that's going to be broken down to 7 and 5. Now, we see that it's a cube, so we're looking for a group of 3, and so we're going to pull out that 5, and we're left over with that 7. Now, we started off with a negative. If you have a cubed root with a negative, we're going to pull that negative out to the front. If you have a square root, it's going to give you an error. Okay, so here's our final answer. Okay. All right, number 6. I saw a lot of craziness on the unit test with this, so let's chat. Okay. First, we're trying to multiply. We're going to multiply the outsides, then we're going to multiply the insides. So on the outside, there's nothing. So we're just going to leave nothing there, right? Now for the x's, when we multiply, we're going to add the exponents. Some of y'all did some wild stuff. What is 7 plus 9? 16. And then we've got the y's, so we're going to add the exponents. What's 8 plus 4? Okay, and we got that 72 just chilling, right? Okay, normally your numbers come first, but it's okay, we're not done. We haven't simplified yet. We're going to break down the 72 into 2 and 36. We're going to break 36 down into 6 and 6. And since this is a square, we're looking for pairs. So we got a 6 on the outside, a 2 on the inside. And now there's 16 x's. So how many groups can we make? How many? 8, yes. So we're going to put x to the 8th on the outside. And then we have 12 y's. So how many groups can we make? Somebody was saying it. 6. Okay. Ta-da! That's our final answer. Now on the next one, it's adding and subtracting. So we got adding. We've got to simplify first and then add it together. So looking at this only, we can't break down this 4 because it won't give us a group of 3, right? We're just going to leave that guy alone. But we've got these x's. How many x's can we pull out? 1 group with how many left over? 2. Okay, on this next one over here, we can break this one down. We're going to say plus 5 cube root of x, 4x to the 8th. We can break this one down with the x to the 8th. That would make 2 groups. Make 2 groups with 2 left over. Now, since we have the same number underneath the radical, we can add them together. Again, some of y'all did some crazy stuff on your test. Okay, we've got x plus 5x squared. Okay, so we're going to have 5x squared plus x, and we're going to say the cube root of 4x squared. Notice how I didn't combine those two. Okay, I just kind of left them by themselves. You do need to put these guys in parentheses because this is also attached to a 4x squared. Okay. The kids who took the interim last semester, they did poorly on the domain and range, and they did poorly on the linear inequalities. Everything else was pretty solid. The reason why they did so poorly was because they did not read the question. Okay. You have to understand what the word in context means. Okay. So each time that we do domain and range, sometimes it changes depending on if we're talking about real world or we're talking about parent functions. Okay. What I'd like for you to do right now and even later tonight is go through unit 2. Okay. So going back up here, and if you already did this, great. You don't have any homework. But unit 2, I would start right here and start going through these problems. Okay. Again, that's where we had a lot of problems last semester. There's at least 3 questions about linear inequality. Writing them, plotting them, like showing the graph. The graph part should be easy, but I understand people struggle with that sometimes. So right now, I'd like for you to do unit 2 and kind of work through these problems. And then tomorrow, we're going to talk about it very, very, very quickly because we got a lot to do. Okay.